Okay, today we are back with the slideshow. Ta-da! Today we're going to talk about mixture problems. Mixture problems are section 4.7 in your book, so you need to make sure that you go ahead and get the problems that I sent your mom for 4.7 and cut them out. That way you'll have them ready to go ahead and stick into your notes instead of having to write them down, because that's a lot of work. So, mixture problems. Mixture problems always have the word mix somewhere in the problem. Okay, always is a stretch. They sometimes have the word mix somewhere in the problem, but they're always talking about combining two things. Combining peanuts and chocolate. Combining hydrochloric acid with water. Combining this solution with that solution. Combining chemicals. Combining tins. Combining mixtures, alloys. They talk about combining stuff together. They usually use the word mix. Not always, but most of the time. So that way you know you're talking about a mixture problem. When you have a mixture problem, they always use the exact same pattern. You get to draw. You have one bucket here plus one bucket there equals another bucket. Because we're going to put something in this bucket, and then we're going to put something in this bucket, and we're going to need something in this bucket. So go ahead and draw three buckets, put a plus there and an equal sign there. It works this way every single time. Inside your buckets is where you write the percents, and below your buckets is where you write amounts. Always a plus here, always a equals there. When you have percents in the problem, the first thing you need to do is put them in numerical order, and then the middle percent goes at the end. We're going to do that with the first problem, you'll see. So, let's look at the first problem. Here's the first problem. Go ahead and tape this one in your notes so you don't have to copy it down. Okay, it says, how many liters of a 40% solution of hydrochloric acid when added to 2,000 liters of a 20% solution is needed in order to obtain a 35% solution? It's a lot of words. But looking at the words, I can talk about how there's taking one thing of hydrochloric acid, adding it to another thing that's a solution in order to get a final solution. So they're talking about mixing stuff up together, which means it's going to be a mixture problem. So I need to go ahead and draw my little buckets. So we got one bucket plus another bucket equals your last bucket. Now, I need to put some numbers in there, and the first thing I have to put in is my percents. So I'm going to go up here and look at my problem. It has 40%, 20%, 35%. Those are the 3% we're talking about. I have to put them in numerical order first. So that means the first one is 20%, because that's the smallest, and then 35%, and then 40%. So 20, 35, and 40. Out of those three, the middle one is the 35. That's the important one, the 35. So that means that 35% has to go here. Which means my other two have to go here. Doesn't matter which one goes where as long as you put them in there. So one gets 20, one gets 40, one gets 35. Okay, now we need to put the numbers in at the bottom. So the only other number they told us was 2,000 liters. And the 2,000 liters, is that talking about 40% or 20% or 35%? Well, it says 2,000 liters of a 20% solution. So the 2,000 liters must go with the 20%. So I'll put the 2,000 liters below my 20%. We don't know how many liters of the 40% solution, so that must be my x. Has to equal our 35% solution. We don't know that one either, but that's not x. We don't know what it is. What we do know is that whatever we put on this side on the bottom has to equal this side on the bottom. So 2,000 liters plus x has to equal 2,000 plus x over here. Whatever's over here on the bottom has to equal whatever's over here on the bottom. And I know it's 2,000 plus x because a big old plus right there. Okay? So there's my problem. Exact same problem we had before on our piece of paper. This is what we should have. Now we need to write the equation. Well, the equation's already here. All we have to do is write it down. So 2,000 times our 20%, 20 times 2,000, plus, because there's a plus there, 40 times x, it's 40x, equals, because there's an equals there, 35 times 2,000 plus x. Notice I put my 2,000 plus x in parentheses. That's because I want to make sure I multiply that 35 by the whole thing, not just the first thing. Also, all of these were percents, but I didn't put any decimals in down here. That's because if you have decimals on this side and decimals on that side, that's a whole bunch of decimals for no reason. So you can do it without the decimals and you'll get the exact same answer and less likely chance of making a mistake. So the first thing I need to do now that I have my equation is draw my line. Do some simplifying on the left hand side, do some simplifying on the right hand side, move my 35x. That gives me 40,000 plus 5x is equal to 70,000. Subtract my 40,000. That gives me 5x is equal to 30,000. Divide both sides by 5. X is equal to 60,000 liters. So 60,000 liters of hydrochloric acid, a 40% solution of hydrochloric acid, added to 2,000 liters of a 20% solution of hydrochloric acid will give you a 35% solution. This 60,000 is really your answer. With mixture problems, there's usually nothing else to plug in. Let's look at another one. Keep in mind that pure solution means 100% and water means 0%. You need to write that down. Pure solution, pure anything, means that it is 100%. Water means that it is 0%. This is a problem. A 30 milliliter solution of alcohol and water is 10% alcohol. How much water must be added to yield a 5% solution? Go ahead, draw your buckets, and see if you can label it correctly. We're supposed to have 3%, right? We've got a 10% and a 5%. What's the other percent? 10, 5. Oh, how much water must be added? And water is 0%. So that's your third percent. 10, 5, and 0. Now try to fill it in. If it's 10, 5, and 0, which one goes in the end? 5%. So these two must be our 10 and our 0. So where does the 30 milliliters go? Well, it says a 30 milliliter solution of alcohol and water is 10% alcohol. So the 30 must go with the 10. We want to know how much water, so that must be our x, which means if we have 30 plus x on the left hand side, we've got to have 30 plus x on the right hand side. Now that we have that, all we have to do is write the equation. What's the equation going to look like? Times 30 plus 0 times x. See, 10 times 30 plus 0 times x equals 5 times 30 plus x. Now that you have the equation, go ahead and solve it. So on the left-hand side, 10 times 30 is 300 plus 0x. On the right-hand side, 5 times 30 is 150 plus 5x. Got to get your x's on the same side, so I subtract 5x from both sides. 300 minus 5x is 150. Subtract 300 from both sides. Negative 5x equals negative 150. Divide both sides by negative 5. X is equal to 30 milliliters. Insert practical demonstration here. Here's the thing. You don't really need to know the practical demonstration, so I'm going to kind of fast forward through this. Hold on a second. I noticed they didn't have any. Oh, you don't need this either. Thus endeth our slideshow for the day. Have a good day. Oh, wait! You need to know about the homework and the classwork. Oh my goodness. What was I thinking? Aren't you glad I caught myself in the nick of time? Homework. Classwork, important stuff. Hold on, I gotta find the page. Boy, I bet you were really excited there for a second, weren't you? Homework, page 163. Wait, classwork first. Page 163 is problems 1 and 3. Then the homework on page 163 is problems 5 and 7. That's it. Not a lot because they're hard problems. But I want you to try them. Okay, bye.